Hey guys, hope all of you are doing well. Uh, I'm back with another tutorial this time, and it's not going to be as long. This is actually a quick one, and you can see on your screen right now. I saw this effect, and this was made by Nick Motion. He does some amazing stuff. Shout out to him. And this looked like it looked really nice. And I just wanted to replicate this in my own way. So I've actually set up the file and I've made it in a way where it's usable and you guys can play around with it as well. So I'll just quickly take you guys through it, and obviously the source file is going to be provided with this. So I just imported this free geometry that I got off of Sketchfab, and I just sort of cleaned that geometry up, rotated it, gave it some nice normals, and so about this geometry, when I first imported it, there was a problem with this was that this geometry had like it wasn't fused together, so it had open edges, unconnected pieces, and that was a bit of a hassle to get through. So a lot of this process over here that you see is merely related to that now. So, and by the way, this can work for every other file as well. So uh, what I then ended up doing was I just cleaned some attributes over here because I think it had some attributes that I did not need, and I just added this UV promote node so that whatever FBX it is that you import into Houdini, you can actually just promote the UV to the vertex class, right? And once that was done, what I ended up doing was I just gave it a connectivity node just to make sure, just to see how many pieces this was split into. And over here you can see like there's a lot going on with this geometry. Like it's not ideal to work on. So just before I plugged in the connectivity node, I just used a fuse node to sort of get rid of all of those disjointed pieces. The value wasn't set too high for this. I think the default value is this, but that sort of just blended a lot of this stuff together, and I just wanted to keep some smaller details in there, so I just used a smaller value for the fuse, and this way it gave me all of these pieces that was not connected, right? So it just stored that in there. Now, once that was done, was what I did was I took this exact geometry and I remeshed it. Um, like with quite a low target size, and I just cached it out. So it gave me this high resolution, high poly sort of a geometry for the exact same thing. Now, this still has some problems, but like it works. Like it works for me. Uh, on the other hand, what I ended up doing was I converted this geometry into a VDB, and obviously because this was not a closed geometry, it couldn't like convert this into a proper VDB, and I just had to give it a VDB reshape node and just use a dilate settings to sort of just thicken the whole thing up, and I converted it back into into a polygon mesh, and then I remeshed it again with the same settings that I used for the thin geometry, and I got basically this thick geometry out of my VDB. Another thing that I added on here was this labs UV transfer node, just in case you have UVs on your original geometry, so you can transfer it over here, right? Once that was done, what I ended up doing was, and by the way, the only reason I used this thin geometry node was so I could do all of my simulations on the thick geometry and then transfer it onto the thin geometry, right? Because that's much closer to the original geometry. Now, once that was done, I just gave it some normals, and I actually created a group, and it was just set to points and bounding box, excuse me, and I just selected a few points on top or wherever it is that you want it to be. Like it doesn't really matter where you select the points, as long as you select some points, right? And after that, I just used a point triangle, and I just told Houdini that the points that I selected on this group active are going to be set at a temperature which is equal to 1. Now what that does is it creates a temperature attribute, and for everything that was not selected it's going to set it at 0, and for everything that was selected it's going to set it at 1. And if you just visualize the temperature attribute, you'll see that over here, that it sort of just creates this mask, right? Once that was done, I used a Pyro Spread node, and for that Pyro Spread node, I didn't really do anything. I just increased the rate of diffusion a little, and these three settings merely just meddle with them to sort of change how fast or how slow your simulation sort of moves. And I cache this out, and if I just take a quick blast for this, you'll see what it does. So as you can see, the mask sort of just spreads across the whole geometry. I'll just close this, and if I just play this back, you'll see that the mask sort of just plays through the whole geometry, right? And there you go. So what it does is it just sort of a very similar thing to Cinema 4D's growth vertex map, right? That's exactly what it does. And once that was done, what I did was I just deleted the attributes that I did not need over here. So I deleted my UV attribute, I deleted my normals, my P, my temperature, sorry, these were actually not deleted. I'm really sorry about that. I deleted all of these attributes that the Pyro Spread node created, and that just gave me a clean set of attributes with temperature, rest, P attribute, and normals, right? And once that was done, what I did was I just split this off into two streams. So I'm going to talk about the ripple solver over here. What the ripple solver actually does is that it sort of just takes your displaced geometry, and it tries to wrap that displaced geometry onto your original geometry, and it does that in a way where it sort of looks simulated as if ripples were going on there, right? And for that, what I needed to do was I needed to have a displaced geometry, right? And since I had this attribute, since I had this mask by the name of temperature that is sort of growing on my geometry, I just used an attribute blur over here to sort of just smooth the edges out. And once that was done, I just used a simple attribute remap, right? And I just sort of created a border for it, right? I didn't do anything fancy. This was a linear curve. I just converted into a bell curve where it just gave me the border for the temperature mask, right? And I imported that into a point warp. And inside of the point warp, what I ended up doing was I imported my temperature attribute, right? And I multiplied that temperature attribute, excuse me, with my normals, because what I'm trying to do is I'm trying to scale along the normals, right? So my normals over here are going to be facing outwards. So if I just visualize my normals, there you go, right? So I just wanted the mask to sort of scale along the normals, right? And only the geometry that is along the border of the map, I just wanted to scale that out. And I multiplied that with a constant value so that I didn't get, so if I just set this to 1, you'll see it doesn't look good. So I just use a constant value over here to scale it accordingly. And after that, I just added that into my p-value. And mind you, because I didn't have to convert this into a float and then back it to vector, because I am just multiplying my temperature with a vector value which is a normal, and then a constant with that vector value which automatically becomes a vector, and then I can add it directly into a vector, right? So that way I get this sort of border, displaced border along my geometry, right? And I know there's some self-intersection going on over here, but the ripple solver takes care of that, right? And I just feed that into the second input of my ripple solver, and I just cache that out. And once I did, what you can see happened is, let me just turn my normals off. What you can see happens is that you get this sort of a ripple going through your geometry. Now, the problem with my the problem with my VDB converted geometry was that because it was a thick geometry, it was sort of intersecting with the inner walls, right? As you can see over here, uh, and there, and there, right? So this didn't really work for me, and which is precisely why uh, I used a thin geometry. Now, it it is a fair question to ask, why didn't I do all of this on a thin geometry in the first place? The problem with working on the thin geometry in the first place was because all of this was not connected, right? All of this wasn't connected. Oh, not the name. Because all of this wasn't connected, right? What it did was that the ripple solver, for some reason, just simulated the ripples on the first part that it ran onto, and it didn't carry the ripples forward, right? So what happened was that you would see the ripples form only on this part over here and didn't carry forward. And I presumed that is why, because that is because this geometry isn't connected, right? So instead, I did everything on a VDB converted geometry. And once that was done, I just used a simple point deform. Now, before the point deform, what I did was I just transferred some attributes from that VDB converted geometry onto my thin geometry, which is over here, right? This is the thin geometry. So the first attribute that I transferred was the displacement, rest, temperature, and thickness. So everything that I kept here, I just transferred it onto my thin geometry, right? Once that was transferred, what I did next was I transferred my class attribute that I created over here onto the thin geometry again. And the reason why I did this was because I was going to be rendering this in Cinema 4D, and it becomes a big hassle if you have an animated alembic which is baked and you want to, sort of texture it, and you want to create selection sets out of it. So what I did this for was that I transferred this class attribute onto my thin geometry, and then I used this little code that I generated from ChatGPT, and I converted my class attributes to primitive groups. And what that did was that it gave me all of these primitive groups over here, and with the help of these groups, what I can do is I can actually use Cinema 4D's texturing tools to sort of just texture different primitive groups if I want to. So this is really handy when it comes to exporting your Olympics. Now, once these two attributes were transferred, I just used a simple, and you'll see, there you go. So you see how that ripple was sort of beautifully uh, transferred onto the original thin geometry. Now I could theoretically transfer this onto the original geometry as well, but the problem with the original geometry was that it did not have enough polygons, so it didn't end up looking that good. So that's why meshed it into remeshed into a high poly thin geometry. Now, after that, what I did was I just remapped the attribute called displacement over here, and I'll just show you a comparison. So this is my displacement attribute, and it's very mid, as you can see over here. Like you can barely see what the displacement looks like, and I just remapped it to sort of increase the separation on that, like to increase the contrast on that. And with that displacement attribute, what I ended up doing was that I actually used a point warp to create a mask attribute. And what that mask attribute was just my displacement attribute and temperature attribute basically just added together. and just use a fit node because the displacement attribute was not fitted into the range from 0 to 1. It was, as you can see, it had some weird values over here. These were the values that the displacement attribute had. And I just added these two attributes over here, the temperature and the displacement attributes, and exported it as a mask attribute. And what that did was it just gave me the temperature plus the added displacement mask like all together, and that it just gave me a little more detail on here. So if uh, I'd have to go to another frame. And by the way, I this setup was made on the rubber duck test geometry that Houdini ships with, and a lot of that stuff was done over here. But yeah, now once that was done, I just use an attribute blur to sort of finesse my mask out. And once that was done, I just used a blast node to just blast out the part that I did not want, right? And I just used a fuse node to sort of just connect any unconnected edges that were there along the geometry. And after that, I just used an edge smooth that ships with lab to sort of smooth the edges along the borders of the geometry. Now this takes a while, like the edge smooth takes a while. Let's just wait for a second so I can show you how it looks like. There you go. And yeah, that's about it. So yeah, that is exactly how I ended up with the effect that Nick Motion made. And if there are any questions, please hit me up and do comment and please hit the like button. Thanks.